Hello viewers, welcome to my YouTube channel Bright Mind to Point, and in this video I'll be explaining how one can identify a soil group using Indian Standard Soil Classification System. IS 1498 1970 describes the Indian standard on classification and identification of soils for general engineering purposes. This system is similar to the US soil classification system, the exemption being that the US soil classification system, the soils are subdivided into 15 groups, whereas in the case of Indian standard soil classification system, the soils can be subdivided into 18 groups. In the Indian standard soil classification systems, the soils are broadly divided into three divisions, namely coarse grained soil, fine grained soil, and highly organic soil, that is peat. In the Indian standard soil classification systems, the coarse grained soils are further subdivided into 8 groups, and the fine grained soils are further subdivided into 9 groups. Highly organic soil and other miscellaneous soils are placed under one group. To describe the soil type, the various symbols are adopted in Indian Standard Soil Classification System. The symbols that are used in the systems are presented. We'll get acquainted with the symbols once we know the classification process. So, as per IS 1498, a soil is said to be a coarse grained soil if more than 50% of the soil is retained on 75 micron ISCS. If the soil is identified as coarse grained, it can be further divided as gravel or sand. A coarse grained soil is said to be gravel if more than 50% of the soil is retained on 4.75 mm ISCS, and a coarse grained soil is said to be sand if less than 50% of the soil is retained on 4.75 mm ISCS. A coarse grained soil, if it is identified as gravel, it can be further divided as gravel with fines or clean gravel. Similarly, if a coarse grained soil is identified as sand, it can be further divided as sand with fines or clean sand. In order to identify whether the given soil is gravel with fines or clean gravel, sand with fines or clean sand, we have to see the percentage of soil passing the 75 micron ISCS. If the percentage of soil passing 75 micron ISCS is more than 12%, the soil is said to be gravel with fines, and if the percentage of soil passing 75 micron ISCS is less than 5%, the soil is said to be clean gravel. Same conditions are applied to identify whether the soil is sand with fines or clean sand. Once we know the identification of the soil, whether it is gravel with fines, clean gravel, sand with fines or clean sand, those can be further subdivided again. If suppose the soil is identified as gravel with fines, it can be further subdivided as GC or GM, where G means gravel, C means clay, and M means silt. If the soil is identified as clean gravel, it can be further subdivided as GW, GP, where again G stands for gravel, W stands for well graded, and P stands for poorly graded. If the soil is identified as sand with fines, it can be further subdivided as SC, SM, where S stands for sand, C stands for clay, and M stands for silt. And if the soil is identified as clean sand, it can be further subdivided as well graded sand or poorly graded sand, where S stands for sand, W for well graded, and P for poorly graded. To distinguish between the soil, whether it is well graded gravel or poorly graded gravel, or well graded sand or poorly graded sand, coefficient of uniformity value, that is Cu, and coefficient of curvature value Cc is to be found out. If suppose the value of Cu is greater than 4 and if the value of Cc is between 1 and 3, the soil is identified or said as well graded gravel. If the value of Cu is greater than 4 but the value of Cc is less than 1, the soil is said to be poorly graded gravel. Similarly, if the value of Cu is greater than 6 and the value of Cc is between 1 and 3, the soil is said to be well graded sand. And if the value of Cu is greater than 6 but the value of Cc is less than 1, the soil is said to be poorly graded sand. The fines that is present in the gravel or sandy soil that can be identified with the help of the plasticity chart, which will be presented further. Next point is to be noted that if the percentage soil passing 75 micron IS sieve is between 5% to 12%, the soil is said to have dual characteristics. As per IS 1498, a soil is said to be fine grained soil if less than 50% of the soil is retained on 75 micron IS sieve. If the soil is identified as fine grained soil, it can be further divided into three groups, namely low compressible fine grained soil, medium compressible fine grained soil, and highly compressible fine grained soil. To judge whether a given fine grained soil is low compressible, medium compressible, or high compressible, liquid limit value of the fine grained soil will be found out, and if the liquid limit value of the fine grained soil is less than 35%, the soil is said to be low compressible. If the liquid limit of the fine grained soil is between 35 to 50%, the soil is said to be medium compressible. And if the liquid limit of the soil of a fine grained soil is more than 50%, the soil is said to be highly compressible. Low compressible fine grained soils can be further subdivided as Cl, Ml, or OL, and the medium compressible soil can be further subdivided as Ci, Mi, Oi, and the highly compressible fine grained soil can be further subdivided as Ch, Mh, or OH, where C stands for clay, M stands for silt, and O stands for organic silt or clay. L indicates low compressibility, I indicates medium compressibility, and H indicates high compressible fine grained soil. Once we know the soil compressibility characteristics, then we have to judge whether the given soil is clay, silt, or organic, and for that purpose, IS plasticity chart is to be used. IS plasticity chart is the chart between plasticity index and the liquid limit. This chart was proposed by Casagrande. It was adopted in the US soil classification system, and further it was modified and adopted in the Indian Standard Soil Classification System as well. For identification of the soil, whether it is organic or inorganic in nature, it can be done by distinguishing the odor and color or finding the liquid limit of the dry soil sample. If the liquid limit of the own dry soil sample is less than the 3/4 of the in situ soil sample, the soil is termed as organic, or otherwise it is termed as inorganic. So this is the IS plasticity chart where the Abisca is represented by the liquid limit and the ordinate is represented by the plasticity index. The three zones on the basis of liquid limit values are plotted here to distinguish whether the soil will be clay or silt. We'll take the help of the A line, which is also called as the Atterberg's line, the equation of which is 0.73 liquid limit minus 20. So this straight line was proposed by Swedish agriculture engineer Atterbergs, and the equation of the line is also proposed by him. This line distinguishes the soil either as clay or either as silt. The soil which is lying above the A line will be termed as clay, and the soil which will be lying below the A line will be termed as silt or organic soil of low, medium, or high compressibility. There are some other features of the plasticity chart as well. So we'll see how one can use the plasticity chart for soil classification and identification. So to identify whether the given soil is clayey or silty, we'll find the plasticity index of the given soil and the plasticity index value of the corresponding to the A line. If the plasticity index value of a given soil is greater than the plasticity index value corresponding to A line, the soil is classified as clay, and if the plasticity index value of a given soil is less than the plasticity index value of the A line, the soil is said to be silty or organic soil. The compressibility of the soil will be judged on the criteria that are already mentioned. The soil that is having the plasticity index between 4% to 7%, such soils are said to have the dual characteristics of both silty and clay, and hence it is said as silty clay with low compressibility, that is CLMM. The fines that is present in the coarse grained soils will also be identified with the help of the plasticity chart, and the same procedure is to be followed as mentioned above to identify the fines present as well. So this is the overall summary, or you can say the overall flow chart of the soil identification using IS 1498. Now we'll take an example and we'll see how one can identify a soil group using IS 1498 with the laboratory data available with us. So there is a laboratory test conducted on a soil sample which gave us the following result, that the percentage finer than the 4.75 mm sieve, or you can say percentage passing 4.75 mm sieve as 60, percentage passing then 75 micron sieve as 30, liquid limit value as 35%, and plastic limit value as 27%. So with this given data, we have to identify the soil type. So first we'll see whether the given soil is a coarse grained soil or a fine grained soil, and for that purpose we'll see the percentage passing 75 micron. Now since that value is less than 50%, the soil is the coarse grained soil, as more than 50% of the soil is retained. Now if the soil is identified as coarse grained, it can be sand or it can be gravel. For that purpose, we'll see the percentage passing 4.75 mm sieve. So the value is 60, which is more than 50%. Hence, the soil is said to be sand. Now, if the soil is sand, it can be a clean sand or it can be sand with fines. To identify this, we'll see the percentage fines that is present in the soil particles. So in this case, the percentage fines is 30%, which is greater than 12%. So hence, the sand will be containing appreciable amount of fines present in it. So what fines are present in the sandy soil? It will be identified with the help of the plasticity chart. So we'll draw a plasticity chart, or we'll take the plasticity chart we'll find the value of plasticity index corresponding to A line. In this case, we got the value is 10.95 and we'll plot it on the plasticity chart. Similarly, we'll find the plasticity index of the given soil, and in this case, the value is 8%, and we'll plot that value on the plasticity chart as well. So, in this case, as you can see, the plasticity index of the given soil is less than the plasticity index corresponding to A line, which means that the plasticity index of a given soil lies below the A line in the plasticity chart. Hence, we can say the fines that is present in the sandy soil is silt, and hence the final classification of the soil can be stated as silty sand, that is SM. So that's all from this video. If you have liked the video, hit the like button, share it with your friends, and subscribe to our YouTube channel Bright Mind EduPoint for more videos relating to the various topics of civil engineering. Thank you.